Alright, number 9. Use the definition of definite integral to evaluate the integral from 1 to 3 of x minus 3 dx. So, these are the painful ones, doing it by the definition. So we get equals limit. This is the limit as n goes to infinity of the sum from k equals 1 to n of xk star minus 3 times delta x. So what's special about this? We get that this is something we can calculate. Delta x is equal to 3 minus 1 divided by n equals 2 over n. Also, xk star is equal to a plus k delta x is equal to 1 plus k times 2 over n. So 2k over n. Now we can plug that in. Integral from 1 to 3 of x minus 3 dx is equal to the limit as n goes to infinity of the sum from k equals 1 to n of xk star, which we just wrote, 1 plus 2k over n minus the 3 times delta x is just 2 over n. Okay, so this is the limit as n goes to infinity of sum from k equals 1 to n of moving the 2 over n over. Let's wait just a second. 1 over n plus 2k over n minus 3, 2 over n. So now I can distribute a little bit more cleanly. This is limit as n goes to infinity of the sum from k equals 1 to n. No, I just confused myself with the way I wrote something poorly. This is 1 plus 2k divided by n. Okay, so how did I know I was making a mistake? My n's and my k's weren't going to match up the way they needed to. And that's how that I noticed that. So, back up, this is limit as n goes to infinity. Sum from k equals 1 to n. This 1 and this minus 3 are going to give me a minus 2. So I have 2k over n minus 2 times 2 over n. And that's everything. So now this is limit as n goes to infinity of the sum from k equals 1 to n of 4k over n squared minus 4 over n. Now I can bust this up into two sums. So I get sum k equals 1 to n 4k over n squared minus sum from k equals 1 to n of 4 over n. What do we have now? Limit n goes to infinity. Now I can pull out constants. So the sum definitely knows that 4 is a constant. Also, it thinks that n is a constant. So I can pull out an n squared and get sum from k equals 1 to n of k minus sum from k equals 1 to n of, well, 4 is a constant, n is a constant, so this is just 1. Now I apply my formulas, limit n equals 1 to infinity, n goes to infinity, 4 over n squared times n times n plus 1 over 2. So these two things are equal by the sum formulas that I gave in the section. Minus 4 over n times n so I'm adding 1 to itself n times, that's n. It's also another formula. So this n and this n cancel. We're left with, I'm going to bust this up into two limits now. Limit as n goes to infinity of 2 times n squared plus n over n squared minus 4. So I get limit as n goes to infinity. Well, actually we're evaluating the limit, right? So as n goes to infinity, that n squared plus n over n squared thing goes to 1. So 2 times that goes to 2. And I get that this is equal to minus 2.